Okay, here is what I'm going to do. I'm going to be reading a definitions for Physics A Level H2 2019. I think it's applicable for AS as well. I'm going to read the word, then I'm going to leave a silence for you to regurgitate and read out the definition yourself, try to, and then I'm going to read out the actual definition. Let's begin. Dynamics. Newton's first law of motion. A body continues in its state of rest or uniform motion in a straight line unless a resultant external force acts on it. Newton's second law of motion. The rate of change of momentum of a body is proportional to the resultant force acting on it, and it occurs in the direction of the force. Newton's third law of motion. If body A exerts a force on body B, then body B exerts an equal and opposite force on body A. Newton. 1 Newton is defined as the force which will give a 1 kg mass an acceleration of 1 meter per second square in the direction of the force. Momentum is the product of the mass and its velocity. Impulse, the product of force acting on an object and the time for which the force acts. The principle of conservation of linear momentum. When bodies in a system interact, the total momentum of the system remains constant, provided no net external force acts on it. Now, on to the next one, forces. Hooke's law. The extension of a spring or wire is proportional to the applied load if the limit of proportionality is not exceeded. Density. Mass per unit volume. Pressure. Force per unit area, where the force is acting at right angles to the area. Upthrust. The vertical upward force exerted on a body by a fluid when it is fully or partially submerged in a liquid due to the difference in fluid pressure. Archimedes' principle. The upthrust on a submerged object is equal to the weight of the fluid that is displaced by the object. Principle of flotation. A floating object displaces a weight of fluid equal to its own weight. Equilibrium. Rotational means that resultant force on an object is zero. Translational, the resultant torque or moment or torque on the object about any axis is zero. Principle of moment. For a body in rotational equilibrium, the sum of all the clockwise moments about any axis must be equal to the sum of all anti-clockwise moments about the same axis. Moment of a force. The moment of a force about a point is defined as the product of the force and the perpendicular distance from the point to the line of the action of the force. Couple. A couple consists of a pair of equal and opposite parallel forces whose lines of action do not coincide. Torque of a couple. Torque of a couple is defined as the product of one force and the perpendicular distance between the two forces. Center of gravity. The point at which its weight or resultant of the distributed gravitational attraction on the body appears to act. Now, work energy power. Work done. Work done by a constant force is the product of the force and the displacement in the direction of the force. Joule. One joule is the work done by a force of 1 Newton when an object is displaced by 1 meter in the direction of the force. Law of conservation of energy. The law of conservation of energy states that energy cannot be created or destroyed. It can only be converted from one form to another. Power. Power is defined as the rate of work done, or energy conversion with respect to time. And now circular motion, angular displacement. Angular displacement is the angle an object makes with respect to a reference line, radian. The radian is the angle subtended by an arc length equal to the radius of the arc. Angular velocity. Angular velocity of a body is defined as the rate of change of its angular displacement with respect to time, period. In circular motion, it's the time taken for it to make one complete revolution, frequency. It is the, what's going on? Of an object in circular motion is the number of complete revolutions made per unit time. Gravitational field. Now, Newton's law of gravitation. States that the 2 point masses attract each other with a force that is directly proportional to the product of their masses and is inversely proportional to the square of the distance between them. Gravitational field. A gravitational field is a region of space in which a mass placed in a region experiences a gravitational force. Gravitational field strength. Gravitational field strength at a point in space is defined as a gravitational force experienced per unit mass at that point. Gravitational potential energy. The gravitational potential energy of a mass at a point in the gravitational field is defined as the work done by an external force in bringing the mass from infinity to that point. Gravitational potential. Is defined as the work done per unit mass by an external force in bringing a small test mass from infinity to that point. So oscillations. Simple harmonic motion. Simple harmonic motion is the motion of a particle about a fixed point such that its acceleration is always proportional to its displacement from a fixed point and is always directed towards the point. Angular frequency. Is the rate of change of phase angle of oscillation and equal to the product of 2 pi f. Amplitude. Magnitude of maximum displacement of the particle from its equilibrium position. Frequency. Oscillations per unit time. Period. Time taken for one complete oscillation. Resonance. When a system responds with maximum amplitude to an external driving force, this occurs when the frequency of the driving force is equal to the natural frequency of the driven system. Now, on to the next topic, wave motion, progressive wave. Progressive wave is one that transfers energy from one point to another without a net transfer of matter. Phase angle.
It's 11:30.
Phase angle of a wave gives a measure of the fraction of the cycle that has been completed by an oscillating particle or by a wave. Phase difference. Phase difference between two particles in a wave or between two waves at a point is a measure of the fraction of a cycle which one is ahead of the other. Wavefront. Is a line or surface joining points on a wave that are in phase. The wave travels in a direction that is perpendicular to the wavefront. Polarization. Is the phenomenon whereby oscillations of a transverse wave are restricted to a single plane. Now on to the next topic, superposition, chapter 12 out of 20. Principle of superposition. It posits that when states that when two or more waves of the same kind meet at a point in space, the resultant displacement at that point is equal to the vector sum of the displacements of the two individual waves at that point. Standing wave. A stationary or standing wave is the result of interference between two progressive waves of the same type at frequency, amplitude, speed, traveling on the same line but in opposite directions. Diffraction. Is the bending of waves after passing through an aperture or around an obstacle. Coherence. Constant phase difference. Interference. Superposition of two or more coherent waves to give resultant wave whose resultant amplitude is given by principle of superposition. Constructive interference. When two waves arrive at the same point with phase difference of 0, maximum intensity and amplitude is obtained. Destructive interference. Occurs when two waves arrive at the same point with a phase difference of pi radian, minimum intensity and amplitude is obtained. Now, on to the next topic. No, actually the same topic, superposition. What are the four conditions of for observable interference? Number 1, the wave sources must be coherent. Number 2, must have similar amplitude. Number 3, must overlap and be of the same type to produce regions of constructive and destructive interference. Number 4, they must be unpolarized or polarized on the same plane for transverse waves. Path difference is the difference in distances that each wave travels from its source to the point where the two waves meet. Young's double slit experiment. X equals to lambda d over a, nothing here. Diffraction grating, nothing here. Give me a second. Nope, nothing. Okay, single slit diffraction. Nope, just need to memorize the formula and apply it. Relay criterion, angular separation between the two forces. Okay, under what condition must the Rayleigh criterion satisfy in order for the two things to be observable? Angular separation of two sources must be greater than theta minimum for the images to be well resolved. Temperature and ideal gas, chapter 8. Heat. Energy transferred between objects because the temperature difference between them. Thermal equilibrium. No net flow of heat between two objects in thermal contact. Two objects are in a state of thermal equilibrium. The zeroth law of thermodynamics. If objects A and B are each separately in thermal equilibrium with a third object C, then A and B are also in thermal equilibrium with each other. Kelvin. Fraction of the thermodynamic temperature of the triple point of water. Ideal gas. Gas which obeys the equation state PV equals to nRT at all pressures, volumes, and temperatures. Now, first law of thermodynamics, heat capacity. Numerical value of the heat capacity of a body is the quantity of heat required to raise the temperature of the body by 1 degree. Specific heat capacity. Quantity of heat required to raise the temperature of a unit mass of the substance by 1 degree. Specific latent heat of fusion. Quantity of heat required to convert unit mass of solid to liquid without any change in temperature. Specific latent heat of vaporization. Quantity of heat required to convert unit mass of liquid to gas without any change in temperature. Internal energy. Determined by the state of systems and is the sum of the random distribution of kinetic and potential energies associated with the molecules of the system. First law of thermodynamics. The increase in internal energy of the system is equal to the sum of the heat supplied to the system and the work done on the system, and the internal energy of the system depends only on its state. Electric field chapter, Coulomb's law, similar to gravitational. force between 2 point charges, proportional to product of charges, inversely proportional to the square of the distance between them, electric field. Region or space in which a charge placed in the region experiences electric force, electric field strength. Electric field strength at a point is defined as the electric force exerted per unit positive charge placed at that point. Electric potential. Work done per unit positive charge by an external force in bringing a small test charge from infinity to that point. Electric potential energy. Work done by an external force in bringing the charge from infinity to that point. Now, new chapter, chapter 18, current of electricity. Electric current. Electric current is rate of flow of charge, Coulomb. Amount of electrical charge that passes through a point in 1 second when there is a constant current of 1 ampere. Potential difference. Amount of electrical energy per unit charge that is converted to other forms of energy when charge passes from one point to the other between 2 points of a circuit. Volt. 1 volt is 1 volt is the potential difference between 2 points in a circuit when 1 joule of electrical energy is converted to other forms of energy as 1 coulomb of charge passes through 1 point to another. Electromotive force. Amount of a source is defined as the amount of electrical energy that is converted from other forms of energy when the source drives a unit charge around a complete circuit. Resistance is the ratio as of the potential difference across it to the current flowing through it. Ohm. Resistance of a conductor when the potential difference of 1 volt across it causes the current of 1 ampere to flow through it. Ohm's law. Potential difference across a conductor is proportional to electric current passing through it provided temperature remains constant. Now for the final chapter, electromagnetism. I think there are 2 more, quantum and nuclear. For electromagnetism, magnetic field. Region in space in which a moving charge or current carrying conductor or any ferromagnetic object will experience force when it is placed in it. Hence, it is known as the field of force. Magnetic flux density. Of a magnetic field is numerically equal to the force per unit length of a long straight conductor carrying a unit current at right angles to the uniform field. Tesla. Uniform magnetic flux density, which acting normally to a long straight wire carrying a current of 1 ampere causes a force per unit length of 1 Newton per meter on the wire. Now for chapter 19, quantum physics. The photoelectric effect is a process in which electrons are emitted from a metal surface when electromagnetic radiation of sufficiently high frequency is incident on the surface. A photoelectron is an electron emitted from the surface of a metal due to the incident electromagnetic radiation. Stopping potential. The negative potential of collector with respect to emitter, which prevents the most energetic photoelectrons from reaching the collector and hence resulting in zero photocurrent. Photon. A quantum of electromagnetic energy. Work function energy. Minimum amount of energy necessary for an electron to escape from the surface of a material. Threshold frequency. Minimum frequency of electromagnetic radiation below which no emission of photoelectron occurs. Wave particle duality. the theory where matter and waves have particle-like and wave-like characteristics. De Broglie wavelength is associated with wave-like properties of a particle. Ignore that. Is the K alpha or the K beta ray higher, taller, more intense? K alpha. And why is that so? This is because the K alpha should be higher than that of the K beta line, because energy differences. Because K alpha characteristics typically occur X-ray is typically greater because the electrons in the L shell are nearer to the K shell. Hence, there is a greater probability that the vacancy in the K shell is filled by an electron in the L shell than from the M shell. Okay, now chapter 20 for nuclear physics. Definition of isotope. Nuclides having the same number of protons but different number of neutrons. Nuclide. Atomic species with specific mass number A and proton number Z. One atomic mass unit is equal to 1/12 of the mass of carbon-12 atom. Mass defect. Difference between the total mass of the separate nucleons and the combined mass of the nucleus. Nuclear binding energy. Energy equivalent of the mass defect of a nucleus. It is the energy required to separate to infinity all the nucleons of a nucleus. Binding energy per nucleon. Total energy needed to completely separate all the nucleons in the nucleus to infinity divided by the number of nucleons in the nucleus. Nuclear fission. Splitting of a heavy nucleus into two lighter nuclei of approximately the same mass. Nuclear fusion. Two light nuclei combine to form a nucleus of greater mass. Now radioactivity. Radioactive decay or radioactivity is spontaneous decay of a nucleus to a more stable nucleus with the emission of an alpha particle or beta particle, and usually accompanied with the emission of a gamma photon. Spontaneous nature of nuclear decay. Rate of decay not affected by external environment conditions such as temperature or pressure. The random nature of nuclear decay. It's a random process. It cannot be predicted which nucleus will decay next. The probability of decay is constant. Per unit time is constant. For radioactive decay, decay constant is the probability per unit time of a decay is of a nucleus. Activity. Number of nuclear decays occurring per unit time in the source. 1 becquerel. 1 decay per second. Half-life. Time taken for the number of undecayed nuclei to be reduced to half its original number. And they're done. Yay, high five. Wait, one more. There is also AC, which we didn't touch on. AC, the root mean square value of current. What does that mean? Root mean square value of current. Average. It is the average current in the DC supply. The current in the DC supply which would dissipate heat at the same rate in a resistor as the AC supply. Yeah. Okay, we're done. So chapter 1, nothing. Chapter 2, we didn't go through because it was straightforward. Chapter 3, that is, we went through. Chapter 4, forces, yes we did. Chapter 5, Chapter 5, Work Energy Power, Chapter 6, Circular Motion, Chapter 7, Gravitation, Chapter 8, Ideal Gas, Chapter 9, First Law, Chapter 10, Oscillation, Chapter 11, Wave Motion, Chapter 12, Superposition, Chapter 13, Electric Field, Chapter 14, Circuit of Electricity, Chapter 15, Electromagnetism, Chapter 16, Electromagnetic Induction, Chapter 17, Electromagnetic Induction, Chapter 15 is actually electromagnetism. Okay, 15, 16, 17 we have covered for sure. Chapter 18 is AC, Chapter 19 quantum, Chapter 20 nuclear. We completed everything. Yes, done. Bye bye.